Welcome back once again. In this video, we are doing a case study problem that's appeared in the sample question paper 2026. And the question is, LED bulbs are energy efficient because they use significantly less electricity than traditional bulbs while producing the same amount of light. They convert more energy into light rather than heat, reducing waste. Additionally, their long lifespan means fewer replacement, saving resources and money over time. A company manufactures a new type of energy efficient LED bulbs. The cost of the production and the revenue generated by selling X bulbs in an hour are modeled as CFX is equal to 0.5 x square minus 10x plus 150 and R of x is equal to minus 0.3 x square plus 20x respectively. That is, one is the cost of the production and the next is revenue generated production, where CFX and RFX are both in rupees. To maximize the profit, the company needs to analyze these functions using calculus. Use the given models to answer the following questions. Derive the profit function. Find the critical points of P of x. Third, A. Determine whether the critical points correspond to a maximum or a minimum profit by using the second derivative test. And third, B. Identify the possible practical values of x, that is the number of bulbs that can realistically be produced and sold that can maximize the profit if the resources available and expenditure on machines allow to produce minimum 10 but not more than 18 bulbs per hour. Also calculate the maximum profit. This is the question. Now move on to the solutions. First question is derive the profit function. Here given the cost function c of x is equal to 0.5 x square minus 10x plus 150 and revenue is given as r of x, that's equal to minus 0.3 x square plus 20x. Let p of x be the profit. We know that profit is equal to revenue minus cost. So we can rewrite it as P of x is equal to R of x minus C of x minus 0.3 x square plus 20x minus 0.5 x square minus 10x plus 150. That's equal to minus 0.3 x square plus 20x minus 0.5 x square plus 10x minus 150. Solving, we get minus 0.8 x square plus 30x minus 150. Hence, the answer is P of x is equal to minus 0.8 x square plus 30x minus 150. Now, in the second question, find the critical points of P of x. To find the critical point or critical values, we find the values of x where p dash x is equal to 0. That is p dash x is equal to 0. First we need to find p dash x and equating that in is equal to 0, we will get the value of x. Here we have p of x is equal to minus 0.8 x square plus 30x minus 150. Differentiate this with respect to x, that is p dash x is equal to d by dx of minus 0.8 x square plus 30x minus 150. 0.8 is constant, x square, the differentiator of x square is 2x and 30 is a constant and differentiation of x is 1 and the constant differentiation is 0. So we'll get minus 0.8 into 2x plus 30. That is p dash x is equal to minus 1.6x plus 30. Now putting p dash x is equal to 0, we will get minus 1.6x plus 30 is equal to 0. That is 1.6x is equal to 30 or x is equal to 30 divided by 1.6. Solving we get 18.75. Hence 18.75 is the critical point of p of x. Third option A. Determine whether the critical points are correspond to a maximum or minimum profit by using the second derivative test. We have p of x is equal to minus 0.8x square plus 30x minus 150 and p dash x is equal to minus 1.6 plus 30. We need to differentiate p dash x again for the second derivative test. So differentiate p dash x with respect to x. P double dash x is equal to d by dx of minus 1.6x plus 30. Here minus 1.6 is a constant, so we can write it as, and the derivative of x is equal to 1. Since p double dash x less than 0, because this is negative, x is equal to 18.75. That's we find out in the previous question is the maxima. Hence we can write x is equal to 18.75 is the critical point corresponding to the maximum profit. And in third B, identify the possible practical values of x that can maximize the profit if the resources available and expenditure on machines allows to produce minimum 10 but not more than 18 bulbs per hour. Also find the maximum profit. Now p of x is equal to minus 0.8x square plus 30x minus 150. It says that the value of x is minimum 10 and not more than 18. So we can write the intervals minus 10 less than or equal to x less than or equal to 18. So we need to find p of 10 and p of 18 and check what is the maximum value. First find p of 8. P of 8 is equal to, put x is equal to 10. Minus 0.8 into 10 square plus 30 into 10 minus 150. That's equal to 0.8 into 100 plus 300 minus 150. That is p of 10 is equal to minus 180 plus 300 minus 150. That is equal to 300 minus 230. That's equal to 70. We have the value p of 10 is equal to 70. Now we are finding the value of p of 18. P of 18 minus 0.8 into 18 square plus 30 into 18 minus 150. That's 0.8 into 324. 18 square is 324 plus 540 minus 150. Hence p of 18 is equal to minus 259.2 multiplying these two plus 540 minus 150. Solving this we will get p of 8 is equal to 130.8. Thus, we can say that maximum profit occurs for x is equal to 18, that is 18 bulbs per hour, and the maximum profit is rupees 130.8. That's all in this video, dear children. Thank you. Stay tuned for the next video. We'll update soon. Once again, thank you.
Need 100 by 100 in maths? Join the Samacheer Kalvi guide. We provide online classes and concept-based videos for class 10 and 12.